Hello and welcome back. This is a video over section 5.5 and 5.6, and this is about factoring binomials. And so we've got some special things here that I want to talk about. And mainly what we're going to talk about is the difference of squares and the difference of cubes, okay? And so what we have here is the difference of squares. And I want you to see that if you have some number a squared minus some number b squared, then this factors out to a plus b times a minus b, all right? And we'll talk about difference of cubes here in a moment, but I want to talk about the difference of squares. So up here, let's come in here and let's write out the difference of squares. All right. And so if I'm talking about the difference of squares, then, let's think about something like this. Let's think about, let's multiply some things out. Let's do some foiling here real quick. So I've got x, let's just do plus 5, and then let's do x minus 5. Okay, and let's keep it simple here. Now, let's multiply this all out, okay? Well, I'm just going to FOIL it first. So I'm going to do x times x, which gives me x squared, okay? And then the outside terms are going to be minus 5x, so minus 5x, all right? The inside terms is going to be plus 5x, so plus 5x, okay? And then 5 times negative 5 is going to give me minus 5 squared, okay? And I want you to see what happens here. These middle terms, negative 5x plus 5x, these add to 0, okay? These cancel out, all right? So what you're left with is this, and you're left with x squared minus 5 squared, okay? Now, we can evaluate 5 squared to be 25, okay? And so when I do this, I've got x squared minus 25, all right? So when I see something like this, x squared minus a number, or any variable squared minus a number, check to see if this number is a perfect square, okay? And so if I notice this, if I recognize this, then I say, okay, well, how can I rewrite 25? All right, and if I rewrite it as x squared minus 5 squared, all right, then I can factor that, and this is an equivalent statement of then doing x plus 5, okay, times x minus 5, all right? So there is a little bit of mental math that's involved here and a little bit of just recognizing that this is a difference of squares, okay? And so I always really like seeing this because when you see x squared minus 5 squared, then I'm just going to factor that and do x plus 5 times x minus 5, all right? So the question is your ability to recognize whether numbers are perfect squares. All right, so let's come up with a list of perfect squares. Now, if I take 1 squared, okay, that's 1 times 1, that's going to give me 1, all right? If I take 2 squared, all right, I'm going to get 4, okay? So all these numbers can be rewritten as something squared, all right? If I do, say, 3 squared, then that's going to give me a value of 9, all right? 4 squared is going to give me 16, all right? 5 squared is equal to 25, okay? 6 squared is equal to 36, okay? 7 squared is equal to 49. And then I've got, say, 8 squared. Okay, and that's going to give me 64. All right, we have 9 squared, which is equal to 81. All right, and let's go up to, I'm going to do 10 squared, 11 squared. Okay, 10 times 10 is going to give us 100. Okay, 11 squared is going to give us 121. Okay, and then let's do 12 squared. Okay, that's going to give us 144. Okay, and then we'll do 13 and 14. Okay, so 13 squared is going to give us 169. Okay, and then 14 squared is going to give us 196. Okay, so all these numbers here are perfect squares. All right, so all these numbers are perfect squares. Perfect squares. All right, so we want to be able to just recognize, when we get those numbers, that we can rewrite those as some number squared, and it helps us identify what we're doing here. Okay, so what I want to do is come over here, and these problems can get a little tricky. But on this one, this one looks kind of oddly similar. What you see here is you have 2 times x squared minus 8 times y squared. All right, so remember, if you see if you can factor anything out of this off the bat, okay? And what I see is I can factor out a 2. So if I factor out a 2, then we're left with simply just x squared, okay, minus 4y squared. All right, now at this point, what you should notice here is that 4 is a perfect square. Okay, I can rewrite this as 2 squared. So let's do that. So I've got this common thing that I factored out, the 2. Okay, parenthesis, here I've got x squared minus, I'm going to rewrite 4 as 2 squared times y squared. Okay, now when I see this, something squared times something squared, what I can then do is this. I can rewrite this as 2, parenthesis, I've got x squared minus the quantity 2y squared. All right, and so what I have here is I have something squared minus something squared, okay? And the trick is to be able to rewrite this. This is kind of tricky to do. But just think, okay, 4 is a perfect square. I write that as 2 squared. Something squared times something squared means that I can write that quantity squared, okay? So then the next step that I would do is I'm going to come up here and, all right, I'm going to factor this. And so I've got my 2 out here, okay? And then what this factors to is just going to be x plus 2y, all right? And then x minus 2y, all right? And that is completely factored. Now, if you're sitting there and you're going, okay, how do I check? Well, you can remultiply this stuff, okay? Multiply it out, and then what you can do then is then just make sure that you get what you started with, and that's how you check your answer, all right? So let's take a look at another one, okay? And so on this one, this looks a little confusing. X cubed times y minus x times y cubed. Well, the common thing that I can factor out of here is a common xy, okay? So if I factor out an xy, all right, then what you're left with is simply going to then be x squared minus y squared, okay? And this is a little bit easier to see, okay? I've got x squared minus y squared. So then I'm going to factor this, and this is just going to become xy times x plus y times x minus y. All right? And that's that, okay? And all I'm doing is just recognizing I have something squared minus something else squared, and I just factor that and take those numbers, add them, and then multiply them by the difference of them. All right, here's my answer. All right. Okay, let's take a look at part C. Now, what I notice here, this one's a little bit different. Off the bat, what I notice is that I have this quantity squared minus another quantity squared. So this is the difference of squares. And what I'm going to do is this. All right, I'm going to rewrite this as the quantity a minus 2, okay, plus then a plus 3, okay? And this is its own quantity, okay? And then I'm going to multiply that by the difference of that. And that's going to be the quantity a minus 2, all right, minus the quantity a plus 3. All right, and I'm just going to leave it like that. Okay, you know, in your ability to kind of sit here and go, okay, this right here is a quantity. Okay, this part over here is another quantity. All right, and so let's go ahead and let's simplify this. Let's combine like terms. So I'm going to do a plus a. So this is going to factor out to a plus a is going to give me 2a. Okay, and then we get negative 2 plus 3. That's going to give us plus 1. So plus 1, okay, that quantity. All right, and then times this part here, I need to distribute this negative, so it's going to be minus a minus 3. So a minus a is going to add to 0, and then I've got negative 2 minus 3 is going to give me negative 5. So I'm really just going to multiply this by negative 5. Okay, and that's it. Okay, so either one of these would be appropriate as answers go. Doesn't really matter, but just kind of showing. Okay, let's move on to the next one. And we've just got 2 of them. All right, now over here, what I'm going to do on this one is I've got 4 terms here. Okay, and so I've got x cubed plus 2x squared minus 4x minus 8. Now, what I can't do here, you know, this has 4 terms in it. All right, so I can't do the normal box method. I can't do any sort of, I can't factor anything out because this has a 1. All these other ones have 2s. So what I have to do is I have to do grouping. All right, and so I'm going to group these. I'm going to change this into a positive plus negative 4x. Okay, I'm going to group that here. Okay, and then over here I'm going to factor out an x squared. Okay, so if I factor out an x squared, then I'm left with simply just x plus 2. Okay, x plus 2. And then over here I can factor out a negative 4. So I'm going to put a plus sign here, and then I'm going to do minus 4. And what I get left with is x plus 2. All right. And so when I factor this out, when I factor out the common x plus 2, then here's what I get. All right. I factor out the x plus 2. And so then I'm left with the binomial x squared minus 4. Now what I notice here is that once I'm factoring this, I can still factor this. Okay, this still, I can rewrite this then as x plus 2, okay, x plus 2 times x squared minus 2 squared. All right, and that is what tips me off that I can continue to factor this. So I've got x squared minus something else squared. All right, and so this is going to factor out to keep my original x plus 2. Okay, and then I'm going to multiply that by x plus 2 times x minus 2. And I'm done factoring. So we want to make sure that once we do the initial factoring process, that we do continue to factor this down until we can't factor anything else. Okay, so if you get to this point and you're like, okay, it's done. Well, no, this is still factorable, okay? And you have to recognize that 4 is a perfect square and rewrite it, and then you get this part over here, okay? All right, let's take a look at part E. Part E looks god-awful, okay? It doesn't look very fun. All right, but what I can do is I notice that I can factor out a 5, and I can factor out a y. All right, so let's see what happens, okay? So what I'm left with, if I factor out a 5y, is this. So factor out your 5y, and then you're left with x squared, okay, times y squared minus 4, okay? Now what I notice here is something squared times something else squared. I can rewrite that as the quantity xy squared minus, and then 4 is a perfect square, and that's going to be rewritten as 2 squared. okay? And I'm going to keep my 5y on the outside. Okay, now what I notice is I have the difference of squares. Okay, so from here, what I'm going to do is rewrite this and say, okay, this is just going to give me 5y, all right? And then parentheses, it's going to give me xy plus 4, I'm sorry, plus 2, and then xy minus 2. All right. So it's all about you guys, finding something you can factor out and then looking to see, okay, is this a difference of squares? Okay, and a lot of times that it is. All right, now let's talk about perfect cubes. All right, now this one's a little bit different. And so for this, I want to go back up here and talk about the difference of cubes. Okay, and so, hopefully you guys see this formula that I used here. For a squared minus b squared, you get a plus b times a minus b. Now, if you see something where you have difference of cubes, okay, and this is cubic functions, I want you to think of the word SOAP, okay, and this is an acronym. All right, so I'm going to put S-O-A-P. Because I always struggled with this, okay? And this deals with the signs, okay? Figuring out which one goes where, all right? So the signs. All right, the first sign is the same, okay? The second one is opposite. Opposite, I think that's how you spell opposite. And then the last one is always positive, okay? Positive. All right, and what I mean by that is when you look at this sign here, this sign is a negative, okay? The second sign, so that's kind of what you look at first, okay? This sign's a negative, and then that helps us determine what these are over here, okay? And so what we get over here is that this is going to be the same, this is going to be the opposite, and this one's going to be always positive, okay? So if we look over here on this one, when you have the sum of cubes, okay, so it works for that. When you have difference of squares, it only works when you have a minus sign, okay? But when you're dealing with cubes, if you see a plus sign, it will still work, okay? And the same thing is going to apply, okay? We're going to have the same sign as what we had. We're going to have the opposite sign from what we started with, and then this one is going to be always positive, okay? So this will always work, all right? So let's go through, all right? And let's create a list of perfect cubes. Okay, include both numerical perfect cubes as well as variable perfect cubes. Okay, so if I take 1 cubed, that's going to give me 1. 1 times 1 times 1 is going to give me 1. All right. If I were to take 2 cubed, okay, 2 times 2 times 2 is going to give me 8. All right. 3 cubed is going to give me, what is that, 3 times 3 times 3? 3 times 3 is 9, times 3 again is going to give me 27, all right? 4 cubed, all right, is going to end up giving me, what is that? 4 times 4 is 16, times 4 again is 64. So 64 is a perfect cube, okay? 5 cubed, 5 times 5 is 25, times 5 again is going to give me 125. Okay. 6 cubed, 6 times 6 is 36, times 6 again I believe is 216. Okay. All right, and we'll stop there. Okay, now if you want to think about something else that's a perfect cube, also think of this, all right? If I were to do -1 cubed, -1 times -1 is +1, times -1 again is going to give me a -1. All right, same thing with -2 cubed. Okay, and what that's going to give me is -8. All right, and so on. So if you were to square or cube any number, okay, positive number, you get a positive answer. But if you cube a negative number, you get negative values. Okay, so all those kinds of numbers are going to be, perfect cubes. Okay, those types of numbers. All right, so The other thing that it kind of talks about is the perfect cube thing. Now, what I want to do is kind of talk about something and how I did this. Now, let's talk about how I kind of did that up in the previous part for perfect squares. Okay, so variables. Okay, now when I take a variable, all right, let's say I have x squared times y squared. All right, what that means is I'm taking x times x, okay, times y times y. Now what I can do with this, cool thing about multiplication is I can reorder this in any way that I want. So if I wanted to say, okay, well let's take x times y and let's multiply that by x times y. All right, and if I group this, you have to think about it. xy times xy would just give me a quantity xy squared. Okay, and that's what we did up in the top on a lot of problems. I didn't really go over how I did that, but that's why. Okay, now if you think about it, if you think of variables, we can do the same thing for x cubed. All right, so let's say that I had that. Let's say I had x cubed times y cubed. All right, what I'm really doing here is I'm doing x times x times x times y times y times y. All right, and I can reorder this and I can say, all right, well, I'm really just doing x times y, all right, times x times y times x times y, all right? So I have these quantities here. X times y 3 times gives me xy quantity cubed, okay? And that's how I'm getting those, all right? So we're going to kind of do that quite a bit. All right, now the other thing here, all right, is this, all right? If I have 125 times x cubed minus y cubed, then what I'm dealing with is this. All right, let's rewrite 125. I notice that that's a perfect square. All right, let me zoom in a little bit. Okay, let me rewrite this as 5 cubed times x cubed, all right, minus y cubed. Now, because I have a common 5 and, or, 5 cubed and x cubed, I can rewrite this as the quantity 5x cubed, okay, minus y cubed. All right? So now this is essentially like, when we do this, this is my A, and this part here is my B. All right? And so if we think about the formula that we had, all right, let's write this out real quick. If I have A cubed minus B cubed, all right, this will factor to the following. All right, this will factor out to A minus B, so same sign. All right, A minus B times A squared, opposite sign, plus A times B, all right, and then plus B squared, always positive, okay? And that's that, all right? So that's how we do that. Now, what I want you to see here is that when I do this, all right, I'm going to, this form here is the same form here. I just have to plug in those values the way that I see them. So if I wanted to factor this, okay, then I would get the quantity, oops, let me use black, okay, quantity, all right, I've got 5x minus y, the same sign, okay, multiplied by the quantity 5x squared, okay, so take that quantity and then square it, and then plus, all right, I'm going to do 5x times b, which is my y value, so 5x times y, and then plus y squared. All right, now we're almost done. We're essentially done except for we can still simplify this part. Okay, I can do 5 squared and x squared. All right, so what I have here, okay, I've got 5x minus y, all right, and then I've got 5 squared, which is going to give me 25, okay, and then x squared, which is just going to give me x squared, okay, and then plus 5xy plus y squared. All right, and that's my answer, okay? So it's all about recognizing and rewriting this to get the form of something reasonable. Okay, now let's take a look over here. All right, now on this one's a little bit different, okay? Now what I notice right off the bat here is that I've got the numbers 8 and 27. Both of these numbers are perfect cubes. So if I were to come in here and factor this, I'm first going to rewrite this one as 2 cubed times x to the 6th plus, this is going to be 3 cubed times y cubed. Okay? Now, x to the 6th, this is kind of where it gets a little strange. What I want to do on this one is rewrite this as something to the 3rd power. Now, my rules of exponents say this. If I take 2 cubed times x squared, that quantity squared, raised to the 3rd power. Okay, when I take something raised to an exponent raised to another exponent, I multiply my exponents, and that would give me 6. Okay, then I still got plus 3 squared, or I'm sorry, 3 cubed times y cubed. Okay. All right, so now I have something cubed times something cubed. All right, I can rewrite this then as the quantity 2x squared, this quantity cubed, okay, and then plus, okay, the quantity 3y cubed. All right, and a lot of this I'm just applying rules of exponents. So if you're really struggling about this, then holler at me and we can talk about our rules of exponents and how I'm rewriting this, okay? So now let's use our definition, okay? Here's our a value, okay? Here's our b value. So it's plus. So now I've got this. I've got the quantity. All right, I've got 2x squared. So 2x squared is my a value plus 3y, okay? Keep my same sign. Then on the next one, I'm going to do a squared. So that's going to be 2x squared, this quantity squared, okay, minus opposite sign, a times b. So I've got 2 times x squared times 3y. All right. And then always positive, we're going to take our last term and square it. So 3y squared. All right, so 3y and then squared. All right, and we're going to close that parenthesis. All right, so now that I've done that, okay, I've got the first part remains the same. All right, so let me do this. Let me do, so I've got 2x squared plus 3y, okay? If I take 2 and I square it, that's going to give me 4. So this term over here is going to become 4. All right, x squared squared, when I do this part, that's going to give me x to the 4th. Okay? All right, now minus, when I multiply all these parts over here, minus 2 times 3, which is going to give me minus 6. So minus 6. And then x squared times y, we're just going to leave as x squared times y. All right? And then over on this side, when I have 3y squared, 3 squared is going to give me, so plus 9, and then y squared. And that's it, okay? And that's all we're doing. So, you know, here's my final answer once I simplify everything. All right, so the key is to, you know, be able to factor it like this, but then to be able to, you know, write it out like that is also important. All right, let's do the last one. Last one's a little tricky. Last one's kind of hard to recognize. What you need to do, again, is rewrite this using your rules of exponents. So rewrite this as x cubed. All right, start with that. Or, I'm sorry, x to the 4th something cubed. Okay? And I can rewrite that and rewrite it so that, okay, if I were to simplify this, x to the 4th cubed means I would take 4 times 3 to give me 12. Okay, so I can rewrite it, but you want to make sure that you've got something cubed. all right? And then minus 1. Now remember, minus 1, this is cubed. All right, so here's your A, and here's your B. Okay, so what you have then is I've got x to the 4th, all right, same sign, minus 1, all right. Uh-oh, I noticed something now. Okay, now once I do that, okay, x to the 4th minus 1 times, I've got x to the 4th quantity squared. Okay, so square that. Plus, opposite sign, x to the 4th times 1, and then plus 1 squared. Okay, so now let's kind of simplify this a little bit. All right, this is where it gets weird. I've got x to the 4th, okay, minus 1, times x to the 4th squared is going to give me x to the 8th. All right, and then plus x to the 4th, and then plus 1. Now, we could still take this actually much further, but I don't want to go any further than this. What I notice here is that, well, let's go ahead and take this further. Okay, I can't factor this any further. I thought I could, but I actually can't. So let's continue this. X to the 4th minus 1. Now, what I notice here is that this part here is a difference of squares. Let me rewrite x to the 4th. Okay, so if I rewrite this, this is going to give me x squared, quantity squared, and then minus 1 squared. All right, and then I'm left with x to the 8th plus x to the 4th, and then plus 1. All right, so once I do that, notice how I have something squared minus 1 squared. So I can rewrite this now as, and let me do it way over here. Okay, it's going to take up a little bit of room. I've got x squared plus 1 times x squared minus 1. All right, and then I've got what I've got left over. So this is x to the 8th plus x to the 4th, and then plus 1. All right, so now what I notice is that I have a true difference of squares here. X squared minus 1, I can really just write this as x squared minus 1 squared. All right, so now let me factor this part. I'm going to write it up front. Okay, so I've got x plus 1. Okay, and then I've got x minus 1. All right, then I'm going to write this part, x squared plus 1. This I can't factor because it's the sum of squares. This does not factor. Okay, x plus 1. And then I've got x to the 8th, all right, plus x to the 4th, and then plus 1. Okay, this is a lot. All right, this factors down quite a bit. All right, now what you'll understand about this is that the more and more you practice this, the better it's going to get. Okay, that's the first thing. Okay, the second thing that you need to understand here is that this skill is extremely, extremely, extremely important when you go on into higher level math classes. Okay, your ability to recognize something and factor it is really important. Okay, these are hard to recognize, all right, but once you do recognize them, they become pretty easy. So this is for 5.5 and for 5.6, so make sure you guys do all these homework problems. And if you got any questions, then holler at me. All right, thanks a lot. See ya. Bye.